Picture this: you're a programmer working late, struggling with a complex bug. Suddenly, you decide to ask an AI to solve it. Within seconds, it identifies the issue, explains the underlying problem, and generates a clean, elegant solution that works perfectly. Now ask yourself, is this AI your helpful assistant, or your future replacement? Today, we're diving into one of the most consequential questions facing the tech industry. Will artificial intelligence eventually replace human programmers? This isn't just an academic debate. The answer could reshape millions of careers, transform how software is created, and fundamentally alter the technology landscape we all depend on. From GitHub Copilot writing entire functions to AI systems designing their own algorithms, the capabilities of coding AI are advancing at a breathtaking pace. Yet human programmers continue to be in high demand, commanding impressive salaries and solving problems of incredible complexity. So which vision of the future is correct? Total automation, or an enhanced partnership between human creativity and machine efficiency? In the next few minutes, we'll explore both sides of this critical question, examining the evidence, the economics, and the unique human elements that make programming so challenging to automate. Whether you're a seasoned developer worried about your career, a student wondering if programming is still worth pursuing, or simply someone interested in how AI will reshape our world, this analysis will provide you with insights you won't want to miss. Get ready to challenge your assumptions as we explore the future of programming in an AI-powered world.
Will AI replace human programmers? A two-sided debate. The case that AI will replace human programmers. AI, artificial intelligence, is on track to replace most human programmers within the coming decades. The evidence for this transition is increasingly compelling and follows patterns we've seen in other industries transformed by automation. Consider how AI coding assistants can already generate functional code from natural language descriptions, debug complex programs, and even design entire systems with minimal human guidance. These capabilities are advancing at an extraordinary pace, with each generation of models demonstrating remarkable improvements in code quality, reliability, and complexity management. The economic forces driving this transformation are powerful and practically unavoidable. Businesses face relentless pressure to reduce costs and increase efficiency, making AI-driven development tools an irresistible option for executives focused on the bottom line. A single AI system can operate continuously without breaks, vacations, or benefits, potentially replacing multiple human programmers at a fraction of the cost. We've already witnessed this pattern play out in manufacturing, agriculture, and customer service, where automation has dramatically reduced human workforces. Programming is simply next in line, following the historical trajectory where skilled labor eventually gives way to automation once technology becomes sufficiently advanced. Historical analogies provide further evidence for this transition. Just as calculator technology rendered human computers obsolete and automated looms replaced skilled textile workers, AI coding systems are poised to displace human programmers. Consider how specialized roles like travel agents, bookkeepers, and telephone operators have been largely eliminated through technological advancement. Programming may seem different due to its creative and complex nature, but this perception is likely an illusion. Most programming tasks involve applying known patterns and solutions to variations of familiar problems, precisely the kind of work at which AI systems excel. Critics argue that programming requires uniquely human creativity, contextual understanding, and empathy for users that AI cannot replicate. However, these objections significantly underestimate the rapid advances in AI capabilities. Modern systems can already understand context, interpret vague requirements, and generate solutions that account for human factors like accessibility and usability. The gap between human and AI capabilities in programming is closing quickly, and there's little evidence suggesting some magical barrier that will permanently keep humans in the loop. As AI systems continue to learn from billions of code examples and human feedback, they will eventually surpass even the most talented human programmers in nearly all dimensions of software development.
The case that AI will not replace human programmers. Despite impressive advances in AI coding capabilities, human programmers will remain essential to software development for the foreseeable future. Programming is fundamentally a creative problem-solving discipline that requires deep contextual understanding of human needs, business objectives, and complex real-world constraints. While AI can certainly generate code based on patterns it has observed, it lacks the genuine understanding required to identify which problems are worth solving in the first place. Human programmers don't simply write code, they translate ambiguous human desires into precise technical specifications, a process that requires empathy, negotiation skills, and judgment that AI systems don't possess. The complexity of software development extends far beyond writing code. Professional programmers spend much of their time collaborating with stakeholders, understanding business domains, maintaining legacy systems, and making critical architectural decisions based on factors that aren't explicitly stated in requirements. These activities require a level of general intelligence and real-world experience that AI simply doesn't have. Even the most advanced AI systems operate within narrow domains and lack the broad understanding necessary to navigate the multifaceted human, technical, and organizational environments where programming happens. The ability to ask clarifying questions, challenge assumptions, and identify unstated requirements remains uniquely human. History offers numerous examples of technologies that were predicted to eliminate jobs but instead transformed and enhanced them. When spreadsheet software emerged, many predicted the end of accounting professions. Instead, accountants were freed from tedious calculations and became more valuable strategic advisors. Similarly, AI tools will likely augment human programmers rather than replace them. We're already seeing this symbiotic relationship develop as programmers leverage AI assistants to handle routine coding tasks while focusing their own efforts on higher-level design, architecture, and innovation. This pattern of technology complementing rather than substituting human work has repeated throughout modern economic history. The limitations of AI systems become particularly apparent when dealing with novel problems, interdisciplinary challenges, or situations requiring ethical judgment. AI excels at problems similar to what it has seen before, but struggles with truly innovative scenarios. Software development frequently involves breaking new ground, creating solutions that have never existed before to problems that are just emerging. This pioneering aspect of programming requires imagination, risk assessment, and ethical considerations that remain beyond AI capabilities. Moreover, critical applications in healthcare, transportation, and financial systems will continue to demand human oversight and accountability that society is unlikely to entrust solely to automated systems.
A nuanced analysis of AI's impact on programming. The reality of AI's impact on programming will likely be more nuanced than either complete replacement or business as usual. Certain programming tasks are indeed highly vulnerable to automation in the near term. Routine coding tasks like basic CRUD operations, standard API implementations, simple data transformations, and straightforward front-end components are already being effectively automated by AI tools. Junior roles focused primarily on implementing well-defined specifications with established technologies face the greatest disruption, as these positions often involve the kind of pattern-based work that AI excels at reproducing. By contrast, programming skills that will remain valuable center around higher-order thinking and human interaction. System architecture that balances complex technical and business constraints, cross-functional collaboration with diverse stakeholders, ethical judgment in algorithm design, and innovation in solving novel problems will continue to demand human expertise. Additionally, programmers who can effectively direct and collaborate with AI tools, understanding their capabilities and limitations while leveraging them appropriately, will be particularly well-positioned in this evolving landscape. Rather than disappearing entirely, the programmer's role will likely evolve toward becoming technology orchestrators and problem definers. Future programmers may spend less time writing individual lines of code and more time defining the right problems to solve, establishing appropriate constraints and requirements, and critically evaluating and refining AI-generated solutions. This represents an elevation of the programmer's role from implementer to director, focusing more on the why and what of software development while partnering with AI systems on much of the how. This evolution parallels what we've seen in other fields, where technology handles execution while humans focus on strategy and judgment. Regarding timeline considerations, we can expect different phases of this transformation to unfold at varying paces. In the near term, the next 5 to 10 years, AI will increasingly automate routine coding tasks while requiring significant human oversight, particularly for complex or critical systems. During this period, programming roles will begin shifting toward AI collaboration rather than raw coding productivity. The medium term, 10 to 20 years, may see AI capabilities expand to handle increasingly sophisticated development tasks, potentially reducing the overall number of programmers needed while elevating the complexity of remaining roles. Long-term predictions become more speculative, but even in a future where AI can theoretically handle most programming tasks, human involvement will likely remain essential for directing these systems toward meaningful human objectives and ensuring they operate within appropriate ethical boundaries. The future relationship between AI and human programmers will not be a simple story of replacement, but rather a complex evolution where roles transform, some tasks disappear while new ones emerge, and the definition of programming itself changes. The most successful programmers will be those who adapt to this changing landscape, developing the uniquely human skills that complement rather than compete with artificial intelligence.